In this video, we're going to talk about finding the slope given 2 points and finding the slope of a line using rise over run. We're also going to make that correlation between slopes and parallel perpendicular lines or neither. Before going through this video, make sure that you've completed the Desmos activity. After the Desmos activity, you are ready to go in this video, and then whatever we do not finish, you guys are going to have to complete those problems. So here we go, let's get started. Slope of a line. So how do we find the slope of a line? There's a couple strategies that we talk about, but they all mean the same thing. You're figuring out what's the rate of change. What's the change in the y's versus the change in the x's. So let's look at line P in that picture. Okay, we can see line P is decreasing, it's going down, so you should immediately know that the slope's going to be negative. The first strategy is by using y2 minus y1 over x2 minus x1. So how would I do that? Well, you need 2 points of your line. So you can see on line P, I guess I was looking at line Q. That one's negative. Line P is positive. Okay, so let's look at line P because that's the one they want us to do first. What is the slope of line P? So I'm going to start by writing down those 2 points. -2, -2, and 1, 2. Okay, if I use the formula, make sure you understand this is the order of the coordinates: x1, y1, x2, y2. It's basically just saying pick one point as your first point. Those are subscripts 1. Your other point, subscript 2s. You plug them in. You're doing 2 minus -2, and you're doing 1 minus -2. 2 minus -2 is the change in the y's. 1 minus -2 is the change in the x's. Simplify that. 2 minus -2 is 4. Remember, if you have two negatives like that, it makes a positive. And 1 minus -2 is 3. So the slope of line P should be positive 4/3. Let's check. So for line P, I'm going up 1, 2, 3, 4. 1, 2, 3. Up 4 and over 3, and that's correct. Okay, let's do the same thing for line Q. So for line Q, I will do that in a different color so we don't get them mixed up. Line Q, the 2 points are -3, 2, and 2, 0. So you can plug them in. Here's another way, though, that's finding the change in the y's. It doesn't matter which point you start with, so I'm going to start with point 1. So what do I do from 2 to 0? What's the change if I go from 2 to 0? Well, that change is down 2, right? -2. What's the change from -3 to 2? That change is going from -3 to 2, it's going up 5. Now, if you don't understand what I just did there, then go ahead and just keep using the formula y2 minus y1 over x2 minus x1. You'll get the same thing. But this should be the slope. I'm going to go back and check it here. Okay, so if I go from point to point, looking at line Q, I'm going down 2 over 1, 2, 3, 4, 5, and -2/5 is the slope. All right, you guys give these ones a shot, okay? So use the formula if you need to, or use the trick that I just showed you to counting the rise and the run. Go ahead and pause the video and take care of that now. Once you're done, resume the video. If you have questions, let me know in the live Zoom session. All right, so if you're doing them correctly on number 1 from that first group, I got -4. Okay, I got 8 minus 0 over -2 minus 0, which reduces down to -4. The second group is very similar to that, so you should be able to do this one as well. This one, it's easier just to count the rise over run, so that's what I did here. I went up 6 units and over 2. That reduces down to 3. I checked it just to make sure. It looks like it is going up 3 and over 1. So the slope of the line of AB is 3. Now, if you don't like to count the rise over run, you can use the formula. Just use the points that they're telling you and plug them in. There is a couple lines here that I want to focus on. So let's do this. Go ahead and pause the video. Try 7 through 12. And then resume once you're done. And we'll talk about those lines I really want to focus on. Alright, so now that you've tried all of them, let's look at the vertical and horizontal lines just to make sure that we understand what those mean. So if we look at AD, line AD, which is the same thing as line AE, so number 10, try that again. So if we're looking here at number 10, that's this flat line. Okay, so let me erase everything else. So focusing on that flat line, what's the slope? Well, if you count the change in the y's and the change in the x's, you're going to see, guys, that there's actually no change in the y's. From -2 to -2 is no change, right? So that should be 0. And then the change in the x's, -2 to 0. -2 to 0 is just 2 units up. Alright, so 2 units. What is 0 divided by 2? 0 divided by any number is 0. So the slope of this line is 0. Okay, so if you have a flat line, the slope is 0, no slope. Now if you have a vertical line, that's different. Vertical line would be like ME. Okay, so that'd be like number 9 here. So if you have a vertical line, how do I represent that? Well, the change in the y's is actually, if I look at those 2 points, the change in the y's is going from 2 to -2, so it went down 4, and the change in the x's is 0. Now when you have a 0 in the denominator, you may recall that actually is not something that we can do. That's not an operation that's possible. So we say that this one is undefined. Okay, so if you have a vertical lines, their slope is undefined. Alright, go ahead and finish these up if you have not, and then once you're ready, go to the back page and let's talk about how this relates to parallel and perpendicular. Alright, now that we're experts at finding slope, let's see how does it relate to parallel and perpendicular, which is really what we're trying to investigate in this unit. So in the Desmos activity, we found out that if lines are parallel, their slopes are the same. Okay, so 2 lines have the same slope if and only if they're parallel. And 2 lines are perpendicular if and only if their slopes are opposite. So perpendicular, we should have figured out that the slopes were opposite. And then they're also reciprocals, so opposite reciprocals, which just means to flip the fraction. And remember, any number can be written as a fraction. So opposite reciprocals. Okay, so let's see how that works here. Example 1, determine A, B, and CD. Determine if they are parallel, perpendicular, or neither. Okay, so we have some points here. Let's go ahead and find the slopes of those lines, and then we can make our call if they're parallel, perpendicular, or neither. So looking at AB, I need to find the slopes of these 2 points. So the change in the y's of these points from -1 to 5, it went up 6 units. And then from -1 to 1, it went up 2 units. So it looks like that slope would be 3. If you're uncomfortable using that strategy, plug them into the formula that we learned on the front page. Slope of CD, okay, so looking at points C and D here, from 2 to 4, it went up 2 units. And then from 1 to 5, it went up 4. Okay, so the change in the y's was 2, the change in the x's was 4. That's giving me 1/2. Okay, and then now it's saying, how do they relate? Are they parallel, perpendicular, or neither? So remember, parallel, they have the same slope. Perpendicular has opposite reciprocals. These are not the same, nor are they opposite reciprocals. So the relationship is neither here. Okay, now let's look at the graph and just check that. So if you look at line AB, its slope went up 1, 2, 3, 4, 5, 6, and over 1, 2. Okay, that's what we got. And then for CD, it was up 2 and over 1, 2, 3, 4. That's what we got as well, reduced down to 1/2. And you guys can see in that picture, they're not parallel, nor are they perpendicular. All right, so what would it look like for them to be parallel perpendicular? So say you had the slope of like 1/2. Parallel to 1/2 would be 1/2. Perpendicular to 1/2 would be opposite, so negative, and flip it, 2 over 1. That would make it opposite reciprocal. Go ahead and give these next group of problems a try, and then we'll jump down and look at that last section. All right, so hopefully you've had an opportunity to look at 1 through 4. On number 1, I found their slopes to be the same, so I said that they were parallel. I used the parallel symbol that we've talked about, which is just the two lines right beside each other. And then number 2, I found the slopes to be opposite reciprocals, 2 over 1 compared to negative 1/2. Okay, so that I used the perpendicular symbol, which looks like an upside down T. Okay, go ahead and keep working on 3 and 4 if you have not. Those need to be complete. And then also try your best to answer questions 5 through 7. What I would do is I would make sure you start with the points and then use the slope from there. Okay, and then make sure you're meeting those requirements. Once again, if you have any questions, let me know during the Zoom. Other than that, that's all that we have for today. I hope you found this video helpful. Thanks for watching, and let's get this complete.